Okay, so today what we're doing is a binomial theorem. Binomial theorem is used to expand things like this. Now that would normally mean 2x plus 3 times another 2x plus 3 times another 2x plus 3 times another 2x plus 3. So binomial theorem is a quick way, a relatively quick way, to get this answer without having to expand them all out. So there's a couple patterns I want us to kind of notice. I went ahead and had my calculator compute all of these answers. And if you notice, in blue, right, the powers of A are always getting smaller, right? Starts with the fourth power because we're, fourth power. And we notice that those powers of A are getting smaller. Then, if I look at the corresponding powers of B, we'll notice that the powers of B are getting bigger, right? There's no B in the beginning, and then it's B to the first, and then B to the second, B to the third. There's no B, then B to the first, B to the second, B to the third, B to the fourth. There's no B, B to the first, B to the second, B to the third. There'll be a B to the fourth and a B to the fifth as well out here. So what we notice is that the first term, their powers decrease, whereas the second term, the powers increase. Now the other thing to look at is I notice that there's these numbers in front, right? Like there's a 1 here and a 1 here. Here was a 1, a 2, and a 1. A 1, a 4, a 6, a 4, a 1, and then a 1, a 5, a 10, a 5, so on. Well, if I were to group those into a pattern, right? So here's that first row. I had a 1, 2, 1, and then I had a 1, 3, 3, 1, 1, 4, 6, 4, 1. These are patterns, right? This is our pattern deal. This is called Pascal's triangle, and you definitely want to write this down. So if you want to pause this and write that down, that'd be great. So the way this is generated is that we add the two previous numbers. So like here, 3 plus 1 generates the 4. 4 plus 6 generates the 10. And we always start with a 1. So if I were to look at this, this would have to be 6, right? Because 1 plus 5 is 6. This would have to be 15. This would be 20. This would be 15. This would be 6. And this would be a 1. That's Pascal's triangle. Now, knowing all of that, we can actually figure out the question I had asked you. Now, I know that my calculator did give us the answer here, but we kind of want to be able to get that without, right? Because that's what we have to be able to do. So my first term here was a 2x. So notice I've got 2x to the fourth, 2x to the third, 2x to the second, and so on, right? And all the way down to 2x to the 0. Now notice it's the complete 2x. So I've got parentheses. And then my other term is a positive 3. So notice I've got positive 3 to the 0, then positive 3 to the 1, positive 3 to the 2, positive 3 to the 3, positive 3 to the 4, right? Those powers get bigger. Now let's say this instead had been minus 3. Well, then we would have had negative 3's in those parentheses. And then the last bit is to figure out what goes in front. Well, I've got 1, 2, 3, 4, 5 spaces to fill in. So if I were to look, this row right here is the row with 5 numbers in it. And notice I just copied them down. 1 went in the first spot, 4 went into the second spot, and so on. Okay. Now, once we have all that, we've just got to simplify the answer. Well, when I'm simplifying, I just figure out each piece, right? So like 2x to the fourth is 16x to the fourth. 2x to the third is 8x to the third. 2x squared is 4x squared. And by the way, 3 squared is 9, right? So I'm kind of simplifying them all. Then I finish my multiplying, and I come up with the answer. That's what it comes out to be. And if I look at what the calculator said, all right, so it's at the top of the, oh wait, sorry, we did a different one here. So anyway, that's what it comes out to be. Now, homework, you're going to do 2 questions like this. Now, I found 2 questions on the ACT that deal with this. Here they're giving us a setup, and they say when you expand it, what's the coefficient of the x to the 4th term? So I wrote it out, right? My first term is 3x. So notice 3x to the 4th, 3x to the 3rd, 3x to the 2nd, 3x to the 1st, 3x to the 0. My second term is a -2. So -2 to the 0, -2 to the 1st, -2 to the 2nd, -2 to the 3rd, -2 to the 4th. And again, I've got 5 blanks to fill in, so I use the 1, 4, 6, 4, 1 to fill them in. And again, that comes right from Pascal's triangle. So you want to definitely have that written down so you can reference it. And the question said, what's the coefficient for the x to the 4th term? Well, I think this is a term with x to the 4th. So if I simplify this, you know, what is 3x to the 4th power? It's 81x to the 4th. 1 times 81 times 1 is 81x to the 4th, so the coefficient is 81. All right, now that was 27. Now this one is number 59. I'm not sure why this is at the end. And I thought, anyway, who knows? Well, my first term is an x. So you notice I've got x to the 4th. And then, let me use a different color here. I've got x to the 4th, x to the 3rd, x to the 2nd, x to the 1st, x to the 0, right? And then my 1s are my positive 1 here. That power gets bigger, we can see, right? And then I've got 5 spaces to fill in, which again, if I go to Pascal's triangle, here's the row with 5 spaces, becomes a very popular row. Copy down those coefficients. And again, they're asking for what's the x squared coefficient, which would be this term right here. Simplifying it up, we get 6x squared, so the coefficient is 6. All right, that's it. Thank you very much.